So this is a practice NMR packet that I'm going to go through a few examples with you, and then you're going to try some of them on your own. For this, you will need your shift table. That would be helpful. I would think up to 4 colors, maybe 5 colors to kind of label the peaks. If you don't have colors, you could always do symbols, and I'll kind of instruct you on that. But this packet is to help you kind of get a feel for splitting patterns, and also where would the peak show up in terms of its chemical shift. So for this packet, you will be given a name, okay? And then you're going to be given the peaks that you have down here. So again, some of these peaks get a little yucky. So from left to right, this first one is a singlet. Then this one here is a quintet, so that means 5. Splits into 5. Quintet is also here, that's another 5, and then you have a triplet. So my suggestion is for you to draw out the molecule, 3-pentanol, and then literally write out all of the hydrogens. I know that in the past we would just write a stick because it was faster that way, but when we're talking about proton NMR, we kind of need to know what hydrogens we're talking about. So because I have 4 peaks, I have 4 unique hydrogens, okay? And why I like this molecule so much is because if I were to cut this molecule in half and fold it on each other, I essentially have the same thing. Since that OH is right in the middle, it's kind of made it somewhat symmetrical in the terms of what you see on both sides of those molecules. So whenever you see a molecule like this, you want to look at each one of the hydrogens maybe as the same thing, because if you look at the ones I just circled in pink, they have a next door neighbor that has 2 hydrogens on it. So they are somewhat similar. And if I look at their next door neighbor here, these hydrogens here, okay, are right next to a carbon with an OH, and then they have CH3 next to them, so those are probably unique hydrogens. Then I got this hydrogen, of course, on the alcohol. That's unique. And then the last hydrogen is probably going to be this hydrogen that is on the carbon that has OH. Now, a couple things to look for in a NMR, okay? First one I always look for is what I call a triplet around 1, okay? That is usually a CH3 group, usually around that 0.91 area. And because the neighbor carbon here, I am the pink hydrogen. So please again, remember, you are the pink hydrogens. Your next door neighbor is this carbon here. It has 2 neighbors. So 2 plus 1 is 3. So that's your triplet. So whenever I see a triplet way close to 1, I know that it's on the end. I know it's a CH3 group. So that is going to be, and it's a relatively large peak, so that means it's incorporating 6 hydrogens. That makes a lot of sense compared to the rest of the hydrogens there. All right, then I can look at the hydrogen that's on the O, which is the what we call the alcohol. So down here on your list here, ROH, the hydroxylic hydrogen. This is the one that's going to give you the most problem on the NMRs because, you know, it says here between 2 and 4, but you will see that this peak down here is a singlet, okay? And what happens is that hydrogen is blocked by the oxygen. So write down blocked by the oxygen. So the hydrogen that's always on any alcohol, that hydrogen can't see any neighbors, okay? So it's screened away from that. So anytime you see a singlet somewhere here and it has no other place, it's got to be the singlet that is from the hydrogen on the OH. Because this hydrogen, what I colored in blue here, that's the hydrogen attached to the carbon that has the alcohol, okay? So if I look at my table here, if the hydrogen's on the carbon that has the OH, it's between 3.4 and 4, okay? So if I look, I do have a peak around 3.4, maybe not exactly 3.4, but it's a quintet. So I am now looking at the blue hydrogen here. So this hydrogen here. Who are the neighbors? Well, again, you're not talking the carbon it is on. You're talking about the left and the right. So this carbon has 2, this carbon has 2, so that's 4 plus 1 is 5. So is that a quintet? Yes, it is. So that has to be that hydrogen, that quintet. So last but not least, you have the yellow hydrogens. And I have one quintet that hasn't been labeled. Well, does it make sense that it's a quintet? Well, if I look over here, this neighbor here has 3 hydrogens, and I can't forget this neighbor. You don't count this hydrogen that's on the OH, but you do count this blue one. So if I am the hydrogens that are yellow, okay, I have 3 plus 1 is 4, plus another 1 because of n plus 1 rule gives me my quintet. So that has to be my quintet. So sometimes with NMRs, it's going to be like a personal preference as to what you start with. Sometimes it's going to be a process of elimination. Sometimes it'll make perfect sense. Okay. All right. So let's look at the next one. Let's look at the next one. So I drew the actual molecule over here, 2-methylpropanal. So I have an aldehyde, okay, C double bond OH, and then I have a carbon, 2 carbons here, and then I have a methyl group off of the second carbon, okay. So sometimes I will write like CH3s like this. That might be helpful for you to kind of do that as well. So I have the NMR. I have a doublet, so that's a doublet way down there. This is an octet, so that means 8. And then I have another doublet, okay, around 1, a little north of 1, okay. And look at the size of the peaks as well. Look at the size of the peaks as well. All right, so I have 3 unique hydrogens. So I'm going to color in what I think my unique hydrogens are. The hydrogen that's the aldehyde hydrogen is always going to be unique. I then have these CH3s, and hopefully that's obvious to you why I drew it that way. And then I have this hydrogen here. Okay, again, personal preference, where you start, what do you look at? Well, I'm going to look at what I call my aldehydes, okay? Aldehyde hydrogen, okay, that's on the C double bond O, is between 9 and 10. Do I have a peak? Around 9 and 10. Yes, I have a doublet. Well, if I am the pink hydrogen, that is the aldehyde hydrogen, does it see 1 neighbor? Yep. So this carbon here has a carbon and another carbon, but this neighbor, this carbon, has 1 hydrogen on it. So it makes sense that it's split into a doublet. So I'm going to color that in pink because that is my, what I call my aldehyde hydrogen, All right. Then I have a doublet way down here around 1. Chances are that's a CH3. Okay, again, it is splitting only into a doublet because if I am the orange hydrogens, this carbon is my only neighbor and it has 1 hydrogen. So that's got to be my doublet here. Again, pretty big peak, right? I could say there's 6 hydrogens there. That makes a lot of sense versus 1 down here is only probably 1 hydrogen, okay? And then finally, my yellow hydrogen, okay, is probably this octet. Well, can I defend that there are 7 neighbors? So 8 minus 1 means there's 7 neighbors. So my neighbor is here. I have 3 neighbors plus another 3, that's 6, and this neighbor as well. Okay, so I have a total of 7. So it makes sense that that is the octet that I see. Now please note aldehydes, this hydrogen is not blocked by this oxygen. This hydrogen sees neighbors. So this is different than the alcohols. So this hydrogen, again, will split and will be affected. All right, so see if you could try propane. Okay, see if you could try propane. All right, so this has a septet and it has a triplet. Again, triplets are always going to be CH3s. It's around that 0.9, close to that 1. So that's going to be pretty obvious to be that. And they're, you know, somewhat symmetrical. I could cut this in half and fold it in on itself. And then septet is 7. So that means it has 6 neighbors. 7 minus 1 is 6 neighbors. So you are the hydrogens, the orange hydrogens. So you have a neighbor on the left and the neighbor on the right, okay? Each one of the neighbors has 3 hydrogens, so you have a total of 6 plus 1 gets you to a septet. So again, use the colors, use your chemical shifts, and figure out who is who. So see if you could try some of this on your own and then check the answer key.